Describing shapes of distributions of data. There are many different shapes of distributions of data, but some of the more common elements and the ones we will be looking at include these. This one is a unimodal and symmetrical bell-shaped curve, also stated as approximately normal. There's your bell shape. These two are skewed distributions. Skewed distributions can be either skewed right or skewed left. Now this one here has a skew, the tail goes to the right, so it is referred to as skewed right. And this one here is skewed left. Skewed left, because the tail goes to the left. Then we also have what is known as a uniform distribution, in which each value has approximately the same chance of occurring. So how do we refer to this distribution again? Well, as a bell-shaped normal distribution. Remember, we have uniform distributions, a normal distribution, and then we have a left and a right skewed distribution. This is a roughly normal distribution. This is blood pressure. Some of the values come out, but that's the way real life is. Here are two normal distributions of carrots and cucumbers. The means are slightly different in the length. Cucumbers have a slightly greater mean, and the cucumbers have a bigger spread, which means it's wider. This is the mean ratings by Amazon department. It is categorical data because it just tells you which department. So we have to be very careful because normally categorical data cannot have a shape unless it is uniform, unless every category occurs with the same frequency. We cannot order categorical data in an unbiased fashion, but this data is about the most uniform we can get in an imperfect world. This data distribution is skewed. Is it skewed left or skewed right? The tail goes to the right, so it is skewed right. So what is this one? This one appears to have a skew. Where's the skew? It is skewed right. This is a data distribution in which we have our champion as the outlier, but it looks normal. However, if you look to behind you and then you look at the data distribution, you'll notice that one side kind of goes wonky. It is skewed left. Look away, then look at the distribution. What do you first notice? I notice a left skew. Centers and spreads. Centers include the mean, the median, and the mode. Their corresponding measure of spread would be standard deviation for mean and IQR for median. We only use the mode for categorical data, so it really does not have a corresponding spread. When you have numerical data and you have a symmetric distribution, as we have one here, symmetric, bell-shaped, for example, the mean, and standard deviation would be the best measure of spread. When you have a skewed distribution, either right or left, and remember, this one is right, that's when the median and the IQR are the best measures of center and spread, respectively. In this instance, the mean of this is probably right around here, maybe over here, but the median, where most of the data is here, and that's why the median is a better example of the center, and for that you would have IQR for the spread. Based upon the shape of the distribution, you want to use the center and spread that would make the most sense. The reason being is that when you have a skewed distribution, you have extreme values. With a left skewed distribution, you have extreme values on the left, and with a right skewed distribution, you have extreme values on the right. So the median is not affected as drastically as the mean would be. The extreme values on this one even though there's only a few of them, they would make the mean move too far from the center. Because this distribution is roughly bell-shaped and normal, we would use the mean as the center, and we would use standard deviation for the measure of spread. This roughly normal bell-shaped distribution has a mean of 8.2, a median of 8, and a mode of 7.9. Which would we use for the center? What value would we put for the center of this? Yes, it would be mean, 8.2. For this data distribution, would we be using standard deviation, or would we be using IQR? Well, it would be IQR for a skewed right or skewed left distribution. And this one is skewed right. Here we have the distribution of carrots and cucumbers again. Again, they're normal distributions, slightly different means. You would compare the means. Why? Because they're normal distributions. Cucumbers have a slightly greater mean, and the cucumbers have a bigger spread. So looking at this data distribution, how would you describe it? Would you use the mean, the median, IQR, or standard deviation? Well, we know that the answers are median and IQR for the spread. Standard deviation goes hand in hand with the mean because you find the standard deviation by taking the averages of the distances of the values to the mean. And then IQR is simply the third quartile of the data minus the first quartile. So it's the range of the middle 50% of the data, the heart of the data.